Okay. So let's do it then. So we're looking at October, November 2020 today. I hope you guys have tried this one. So let's try and do this. So the first question is about the field of a force. So it's general field question. So you're going to say it's a region where an object, see, wait, where an object feels a force. So that would be the answer. And then define gravitational field strength. So that is
Sir,
4. Yes.
for the field of force one, that's enough for 2 marks?
Yes.
What's the like mark distribution?
I think when you write it's a region, this is 1 mark, and then rest of it is 1 mark. You don't have to write anything else unnecessary. Unless they say what kind of field it is. You get it?
Alright.
Then define gravitational field strength, just force acting per unit mass. And then it says isolated uniform sphere. Calculate the gravitational field strength at the surface. So G is equal to Gm over R square, 6.67 times 10 raised to negative 11. The mass is 6.42 times 10 raised to 23 divided by 3.39 times 10 raised to 6 whole square, like that. All right. What was the answer here? Anybody has done it? Please let me know.
3.73.
3.73. Okay. So then calculate the height above the surface of the planet at which the gravitational field strength is 1% less than the value at the surface. 1% less means that it should be 99%, right? So 99% would be 0.99 of 3.73. Can you find this, please?
3.69.
3.69. Okay. Now, what we're looking at is we are here from the center. We want to find somewhere here the field strength. But at this point, it's 3.69. And you guys need to understand that this is like the radius of that plus it says you got to find the distance above the surface. So we got to find this d. And this is the total r. Okay, like that. You can do something like this. It's better. Now you're gonna do g equals to gm over r square. We'll find this r. So r will be equal to 6.67 times 10 raised to a negative 11. Wait a second, please. Hello. Walaikum salam. आप मुझे थोड़ा सा टाइम देंगे 1 घंटे का उसके बाद मैं आपको जी मैं आपको जी ओके थैंक यू and then it's gonna be G 3.69 and we got to take under root because it had square on the top but you get R as
3.41 times 10 raised to 6.
6. Now this R is basically this R plus D. We want to find the distance above the surface. So we got to subtract this value from the radius. The radius is already given 3.39 times 10 raised to 6. What you get?
2.0 10 power 5.
2.0 times 10 raised to 5. Okay. So that would be the answer. Any questions? Please let me know.
Oh, sorry, it's
So it's 10
10
power
raised to power
5.
4.
10 raised to 4. Okay. All right. No problems. You guys sure about it? All right. Good. Now let's go to this question. Thermodynamic is my favorite chapter. It's easiest. So, what does plus Q mean? It's basically when heat is supplied. Now, the key word here is to write to the system. And plus W means work is done on the system. All right. If this was negative Q, heat is supplied like to the surroundings, or you could say heat is lost by the system, and minus W means work is done by the system. Anyway, so going to this question, it says there is something. Whenever there's an enclosed shape like this, okay, so you should automatically understand it's related to when internal energy becomes zero when you reach the same point. So keeping that in mind, let's go and check. It says show that the magnitude of work done during change AB is 390 joules. AB. Okay. So at A, if I clearly see it somewhere in the middle, and that value is, I don't know, it's 2.2, should be 2.24, 2.28, 2.3.2. So this will be 3.0 exactly. No, sorry, 2.3 exactly. And the other value that I see is, what is this? 3.8, right? Am I right? Okay. So basically, work done is given by pressure times change in volume. The pressure I did not see. It was 2.6. Check the units if it's in SI and everything else. So 3.8 minus 2.3. Okay. So first that side pressure 2.6 into 10 power 5 times 3.8 minus 2.3, and this gets multiplied by 10 raised to minus 3 because that was written right here. Okay, what you get? Should get the same answer now.
Yeah, 390.
390 joules. Okay. Then says state and explain total change of any internal energy during one complete cycle. So internal energy change will be zero, and the reason is that there is no change because when you reach the same point, you guys should understand that if you reach, like if you start from A and you come back to A, it means you have basically come back to the same condition. Same condition means that obviously this represents temperatures at different points. So reaching A would reach the same temperature, which means net internal energy would not change. Okay, so I would say that basically if the gas returns to same point, the change in temperature is also zero, and that is why internal energy is zero, because internal energy depends on 3 by 2 nk delta t. That's why. Is it clear, everyone? Now, so keeping this in mind, then during change AB, 3 is transferred to the gas, which means A to B, you got to take it positive, right? Work done from A to B, we just found out to be 390. Okay. Work done has to be 390, but then we have to see whether it's positive or negative. So how do we see this? If the gas was expanding, like if there was a volume increase, then we take work done negative, and if the volume was decreasing, then we take it as positive. So let's see what happens. So between A to B, it basically expanded from 2.3 to 3.8, which means that the work done has to be negative. And to find internal energy, you can always use this formula, U equals to Q plus W. So what would you get here when you add these two?
Plus 980.
Plus 990. Then we have to see what happens to B2C. No thermal energy enters or leaves, so B2C no energy. The work done on the gas during this change is 550 because they have not said it is negative. We will see. Okay, we will see. So we'll see what happens here. So it's B to C. So B it was at higher volume and C it was lower volume. So obviously it has gone to decrease the volume. So it has to be positive then. And which means if you add them together, you should get plus this. You guys get it? Now, the rest of the column is missing, but we must have some clue about it. So A, B, that change is happening from C to A. What is happening C to A? Pressure is changing, volume stays constant. So if the volume stays constant, that means that pressure work done is pressure times change in volume. If the change in volume is zero, then work done has to be zero. It means at least we know this, that the work done in this change has to be zero. And then we'll use the idea from this in the last one. So when it reaches from A back to A, through all of this, you should understand that the net internal energy should be zero. So if we are finding this value, so what are we going to do? We're going to add all of these. Let's call this X for now. So plus 980 plus 550 plus X should be equal to zero. So what you get for X?
Minus 1530.
1530. Okay. And then obviously you put back, you go back to this formula, add it to this. So what you get for Q then? It should be, I think, same minus, right? 1530. Do you guys understand this? Any questions? Please let me know. Okay. Going to question 3 then. What is meant by simple harmonic motion? So simple harmonic motion has two conditions. Number one, the magnitude of acceleration is directly proportional to magnitude of displacement. So this is the first condition. The second condition is that direction of acceleration is always opposite to direction of displacement. So if these two conditions are met, obviously that body is said to be in SHM. Okay, the next. So now we have this. Anytime you see this, the only thing that should come in your mind is this formula. The relationship between velocity and the displacement is such that plus minus omega root of x naught squared minus x squared. Now, if you forget this formula at any time in the paper, you can go back. And I hope this formula, I'm sure that this is given. It's right here, okay, right here. So you can always remember this if you forget about it. Anyway, now going back. So now it says determine the frequency of the oscillation. Now, obviously, if you know this formula, you can find it. So you can basically look at any value. So I would want to take some easy value. I would like to take this value as 0 and this value. So any value on the graph. This is exactly 0.25, I think. Okay. And this is in meters per second, which is great. So we're going to use the formula 0.25 plus minus. We want to find omega. X naught is the maximum value right here, which I believe has to be 8.4, 8.8 centimeters. So we got to change that. 8.8 times 10 raised to minus 2 whole squared. And at that point, the displacement has to be 0. So that's 0 squared. So can you find omega, please?
2.84.
2.84? Okay. And now because we want to find frequency, so omega is 2 pi f, and then frequency will be 2.84 divided by 2 pi, and that tells you
0.45.
just remember that this value, like x naught, is a constant, and it will always remain a constant. So you can find it from here or here. It always remains the same. Okay. In other way, you could have also used like v naught equals to omega x naught. That is also a way of doing this, and that's I think easier than doing this, but it's up to you. Then you would have to take the same velocity maximum, and then that. Anyway, so then it says period of oscillations given, determine length. This, so we have the frequency, and time period is 1 upon frequency.
Sir,
Yes,
for the previous question, can't we use the formula of V is equal to RW?
that's the same thing. V equals to RW. This shows amplitude, and this is
Yeah.
also it doesn't matter.
Well,
Both
but I got a different answer.
okay. 0.25 equals to omega times.
But I used a different point though.
No, you can't use different points.
Oh,
Either you take, like, you have to take in this. You need to understand that this is the amplitude, and the amplitude means that these points should be taken. None other points represent this. You get it?
okay.
Now coming back to this. So time period is 1 upon frequency. So I'm going to do 0.45 equals to 2 pi. L G is 9.81. What you get for L?
1.2.
1.2. So this is like the easiest question I've seen. Anyway, then, and the pendulum consists of sphere Q suspended by a thread. Spheres P and Q are identical. The thread attached to sphere Q is longer than the thread attached to P. Eh? Okay, sphere Q is displaced and then released. The oscillation of Q have the same amplitude as the oscillation of P. Sketch the variation of velocity and displacement. Oh. So they have the same amplitude, right? But the question then remains, what happens to velocity? If they have the same amplitude, one thing I can tell you is that without even thinking, is that the amplitude on the graph, which is the x naught values, should be the same for the other circle. Okay. But we need to see what happens to velocity. So sphere Q has longer thread. Longer thread would have larger time period. Don't you guys think so? Longer time period would mean that omega, which is 4 by 3, longer time period means omega will be shorter, and v naught is omega times x naught. If this is same, if this is smaller, then v naught should also be smaller. Don't you guys think so? I hope you guys agree. Which means then we don't have actual value, so we can just estimate. Just take 0.2. You can take any other point if you want to, and just make a nice elliptical enclosed shape. Is it clear? Okay, how many marks this one's? 2. So this should give you 2. Any questions, please let me know.
Sir, could you repeat part D again?
Part D, yes. So basically in the question, this whole circle represents v naught equals to omega times x naught, right? It says that one, like Q has a longer length now, but they share the same amplitude. Same amplitude means both have the same x naught value. You get it? So that means that our graph should start from the same x naught values. You understand? The next idea is, how did I figure out how the velocity is going to change? Okay. So I realized that basically the formula they've given here with respect to time periods, I'm going to write it here. It's 2 pi L over G root. If you notice, G is constant, this is constant, so time period is proportional to under root L. So if you increase the value of L, don't you think the time period will also increase? Yes, Javeria. And then, if the time period increases, it means omega, which is also 2 pi by t. If the time period increases, they're inversely proportional. A slanted
So that
bubble
would
means
decrease, yeah.
decrease. If this decreases, then don't you think these two are directly proportional? Then this would also decrease.
It would, yeah, it would definitely.
That's why I have decreased the y-axis magnitudes. Okay.
Right. Okay,
Yes.
sir.
So that's my thought process. You can actually see it, and if you still don't get it, do let me know. Then we have ultrasound. Okay, so 4 mark question. And what is it about? It is about the generation. So I've also written it in notes, so you can also write that you have to write quartz crystal is used, alternating potential difference is applied across it. This is the second point. The third point is that it is then made to resonate. And how it resonates? When natural frequency matches driven frequency, driver frequency, okay? Whatever frequency of that potential differences. And fourth point is that this causes sound to be generated in ultrasound range. Is it clear? Unfortunately, you need to rote learn this because there is no other way. Anyway, by the way, decibels is not in our course anymore, but we can definitely find the intensities of these two. I think so. So how do you find intensity? So we're not doing it in decibels. We'll do in just a ratio. Okay. So intensity is given by I equals to I naught E minus mu x. We want to find the intensity of I over I naught because I naught is when it is entering air and then when passing through the layer of air, right? So we get minus mu x. This is what we need. So the linear absorption coefficient is 1.2. It is in centimeters. We just need to multiply it in centimeters as well, which is great. What you get?
Zero point zero 0.0499.
1499. Okay. 0.015. Okay. Perfect. Right. Is it clear, everyone? Then says define electric potential at a point. So electric potential first mark would be when you write work done per unit charge. Now in moving a positive, right? Positive writing, like this word is important keyword, please. Charge from infinity to a point, okay? So writing this is essential. Remember this. If you have any questions, let me know. Now, going to the next then. So we have a graph. This is a net graph of potential, as I can see. So this is charge and charge. No charge is given. And then it says determine the charge of B. Okay, we can do that. We can definitely do this. So we have to find the potential at 2 points. We have to make sure that this point is somewhere in the middle, and that's 10, which means this would be 15, this would be 16. So this is 15.5. And here, charge is also in the middle, which I believe is 34, 35, 34.5. And this is given in 10 raised to power 2. Oh, interesting. Right. So then, V is equal to KQ over R. That's what we're going to use. But I don't think so we have the radius, right? We can use one of the, but V is like on this side. V is on this side and X is here. X is the distance between these two. Right. So I'll just use this, I think. This value seems like 11. But that doesn't help, That really doesn't help me at all. So instead of doing like, wait a second, very strange, yeah? So, oh, they have already given the charge. So, what is the issue then? Why can't we take this point then? If we take this point, that would help us determine everything because potential here is 0. The potential of this and potential of this. Okay. So, at this point, we can say the net potential is 0. If we add the potential here, all of this and all of this, it should come out 0 at this distance. Okay. So from here, like from x when it was 0, because they haven't given us anything. So this means if at this point, if this was 0 and this was 4, like 0 to 4, so this was 4 right here, this distance is 4, then this distance would be 12 minus 4, 8, right? With the potential 0. So I'm going to say the change in potential is 0 and the potential needs to, or you could say the net potential. That's better. So what you're going to do, you're going to say kq over r square plus kq over r square. By the way, potential adds up with this sign should be considered. So it has to be 0. Then 8.99 times 10 raised to power 9. The charge on the first one was 2.0 times 10 raised to minus 9 divided by the distance was 4.0, and I think we should convert this into meters, plus 8.99 times. This has to be taken as negative. The reason why I'm taking it negative, because I know that if it is in the negative potential side, this charge has to be negative. There's no other way. Divided by this distance was 8.0 times 10 raised to power minus 2 equals to 0. So what you get as charge? You will find the magnitude of this. Interesting question.
So 4.0 times 10 raised to minus 9.
And because this charge was negative, so put a negative sign. Because obviously it has a negative potential. That's why. Then says the electric potential when point P moves from position where x is equal to position where x is this. Now, okay, so we got to do that. The change in electric potential when it moves from 9 to 3. First, we need to see where the 9 is. So at 9, it is right here, which is minus 10. And at 3, it is here, which is equal to, what is this? 2 minus, plus 2. Okay, let's do that. So the change is going to be, it was at basically 2 minus 10 into 10 raised to power 2. So that's going to be 12 into 10 raised to power 2. Now you might be wondering why I would do 2 minus 10. Why can't I do minus 10 minus 2? The reason I cannot do this, I just want you to write on your paper as well, so you guys remember when you're looking at it again, that this is a scalar quantity, and I've also, pointed out before, in scalar quantities, you always do larger minus smaller when you're finding change. In vector quantities, you do final minus initial. All right. So do remember this, please. This is very important. Otherwise, you might get a wrong answer for this. Any questions now? Okay. Going to the next then. It says alpha particle moving through the line AB. The alpha particle moves from position 9 to where 3 is. Use your answer to calculate the speed. Okay. So what is really happening here? It's basically gaining some potential, all right? So we can say that the loss in kinetic energy goes to gain in potential energy. The kinetic energy is half mv squared. The gain in kinetic potential energy is q times vq. Okay, so let's do this. Half times 4q, that's the mass of alpha particle. If you don't remember, that's a big shame. But then it's all right. Now you know. The charge on alpha particle is 2e, and the change in potential is this. So let's remove u. It's 1.66 times 10 raised to minus 27 times v squared. 2 is 1.6 times 10 raised to minus 19 and 1200. Can you find v, please? Okay.
Sir, 3.4 times 10 raised to 5.
10 is to 5. All right. So I hope you guys understand this. Let me know if you have a question. Okay. So let's go to the next.
Sir, could you explain that question again, please?
This part.
Yes, sir.
So what happens is that at 9, it had minus 1000 volts. Okay. That's 9 centimeter. At 3, it had 200 volts. You get it?
Yes, sir.
So obviously, when you go from a lower potential to higher potential, what you got to do, you must have some kinetic energy that must change into potential energy. You get it? So the
Yep.
amount of kinetic energy you have should be equal to the amount of potential energy you have. Now, alpha particle has 4u mass and 2e charge. So I just put mass here, I put charge here. Potential difference was 1200, and I used the equation. Get it?
Okay, sir, yes.
Cool. Okay, then we're gonna go to the next, which is the capacitance of a parallel plate capacitor. So for this, obviously, you guys need to write that this is the charge per unit potential difference. Okay, this would give you 1 mark, and the other mark should be that writing charge on one plate and potential difference across the plates. That's how you do it. So 3 functions I've given you like a lot of them. You can write anything. So if I were you, I would say time delay, buffer circuit. Buffer and time delay is the same. So you can say tuning circuit. What else? You can say smoothing. You can say surge as a surge protection device. You can also say you can basically use it to control the amount of direct current. But that's something. But you can write any three functions you want to. Oh my god, I've never seen this, but it seems very easy because whenever you see a complicated circuit like this, you start your finger, move your finger from one point, and then wherever you need to decide where to go, that two branches are parallel. So these are parallel, but if you keep on going here, all of these are in series. So this whole section is series, and this is parallel with this. I guess you got to remember this. Anyway, now it says calculate the combined capacitance. So in series, the capacitance is combined by taking reciprocals. So what that might be 3 over 24. What is 3 over 24? 24 divided by 3. So that's going to be 8, I think, right? And then you can add them. So the total capacitance would be 8, and in parallel you just simply add them. So it's going to be 32. All right, is it clear? And that's it. Oh my god, this was easy. Okay, no brainer really. Okay, this is out of the syllabus. I also used to love this chapter, so easy. Anyway, going to 8. So there's a magnetic flux density, there's a direction of movement electrons, blah blah blah. It says electrons enter into state direction of force on electrons due to movement of electrons in the magnetic field. Now, so your index finger must be right here. So this is your index finger. Your middle finger of your left hand should be right here. And then, can you guys tell where your thumb is? Please try. It's something you're learning from your IGs.
Upwards.
Upwards. The thumb is upwards, but that's only true for positive charges, which means for electrons it would be opposite. It means you would write it's downwards. Do you guys understand? Or for electrons, you can use Fleming's right hand. So same rules, just right hand. So that would also give you downwards. It's up to you. So now let's go forward. Identify the phases using between the potential differences developed. Obviously, when the electrons are like going down, so J, K, L, M would be negative and P, Q, R, M will be positive. Okay. So you're going to write P, Q, R, P, Q, R, S. And the phase K, L, M, J, K, L, M. These two phases will be your the charged phases. Explain why potential difference in one reaches a maximum value. Obviously, as electrons keep on going down and keep on depositing on the other side, so relatively a positive charge develops on the other side. At one point, the magnetic field and electric field will be equal, and that's when electrons cannot deposit anymore, and you will have a steady value of current. So we're going to write that. Okay. So we're going to write as electrons are deposited on JKLM phase, PQRS becomes more and more relatively positive. Okay. Hence, an increasing electric field is developed. Now, for the other point, you're going to say when electric field and magnetic field we should write electric force actually. Force and force. When electric force and magnetic force are equal and opposite, the electrons do not deposit anymore. Hence, a steady value of potential difference is achieved. This is basically what should be written. Okay. Any questions? Please let me know. Okay. So, going down then. The number of free electrons per unit volume in the slice material is this, and the thickness of this is this, and blah, blah, blah. So calculate potential difference of across the slice for a current of this. Okay. Now you need to remember that in a Hall probe, the equation for Hall voltage is BI over NTQ. Okay, so nobody's going to tell you that. I'm not sure if this is given. Let me see. Wait.
It is, sir.
It is given? Okay, you're in luck then. You don't have to remember this, but you should know that this is going to be used. Okay, it's here. Cool. They're nice people. Okay. Let's go and check this out. We've done a lot. Okay, so the magnetic field strength is 4.6 times 10 raised to minus 3. The current is 6.3 times 10 raised to minus 4 divided by, this is N, okay, electron density, 1.3 times 10 raised to 29. And what you get is thickness. Thickness is in millimeters, so obviously you're going to change that. And what you get is, the next thing is charge. So charge on electron is 1.6 times 10 raised to minus 19. And what you get,
(1.4 times 10 raised to minus 12).
do you think these significant figures are okay? Who can tell me if this answer is okay to write? Why can't we write 1, or why can't we write more than 1.4? Or can we?
So the data
because
is clear, sir.
Because every value is like two significant figures. Yes. Every value is the same. So we have to make sure that we write the same significant, or just one more than that, not more than that, or less than 2. Okay. In this case only. So the slice is a metal. Slice and C is a metal. By reference to your answer says why Hall probes are usually made of semiconductors. And this question repeats a lot. So you guys need to understand that obviously, if you look at the formula itself, N and V are inversely proportional. So if the smaller the value of N is, the greater the Hall voltage is going to be. So generally, in metals, the number density of electron is much higher. So you use semiconductors because they have a they have a smaller value of N, which means you'll get a larger value of VH. Okay, so that's what you're going to write. You're going to say semiconductors have a much smaller value of N. So what does it do then? So VH will be larger, hence it has less uncertainty. You can write uncertainty or can be easily measured. You can write both because that's the same thing. Is it clear, everyone? Pretty good. Now let's go forward. Now comes magnetic flux. Magnetic flux is defined as V times A. So I always remember these with the formula. So I know that flux is a unit, like it's a quantity that depends on the magnetic field and area. So I'm going to write it is the product of magnetic flux density times perpendicular area. Perpendicular area, writing perpendicular has 1 mark, okay? And the other things have 1 mark. So just remember this. This is a keyword that you should not forget. Interestingly, the transformers are removed from the syllabus, so you don't have to worry about that. So, cool thing. Anyway, we're going to go to the question 10. How many medical questions they're going to give us? That's not fair. So now briefly explain the principle behind CT. Okay. So we're going to say X-rays are used in CT scan. Number 2. To scan a section of an object. All right. Third point. The scans are repeated at different angles. You can write many angles as well. Fourth point. Then the scans of sections are processed and combined using a powerful computer. And for the fifth point, then the 3D image of the object is generated. That's how you're going to write it, okay? If you have any questions, do let me know. Again, this is rote learning. Can't help you if you don't remember these things. Anyway, let's see what's ahead. Okay, this is easy. So first of all, they say that the section is viewed in turn from 4 different directions, and they've shown it to you. Cool. And they say that the detector reading for each direction noted, and this sum, and this is the value taken. Now, if this question comes, they will always give you a background reading. Now, obviously, you guys need to remember how to go back to the original section. So how will you go to the pixel numbers? I gave you a formula. Who's going to tell me that formula? Cell yes.
Minus background divided by 3.
Cell minus background divided by 3. This is when going from the basically going from like this to the original one. Okay, so if you go to the original one, that's when you use this. And if you go to any this to this, then what you use? Wait, if you go from this to this, you use cell minus background divided by 3. And if you go from this to this, you do cell times, you got to do basically this value times 3 plus background, right? Yes, something like that. Anyway, so let's do this. So what you do next is that you take one of these, 42 minus 24, and divide by 3. What you get? Go on, lazy people. I have to do it on my own. That's not fair. 42 minus 24 divided by 6. Okay. Then next is going to be 45 minus 24 divided by 3. What you get?
7.
This is L. Okay, 7. Then 51 minus 24 divided by 3.
9.
9. Okay, and 30 minus 24 divided by 3.
2.
2. Okay, and done. That's it. Only remembering these two formulas. If you do this, obviously you're never going to get this question wrong. Anyway, so going to the next 10.
Sir, how much of that do we need to know? Because I never
Sir,
see
M
you.
is 2 and N is 9.
Hmm?
M is 2 and N is 9.
Okay, whatever you say. You just need to know this. That's it. Okay. All right, Narjis.
They won't ask anything much harder, right? Like just like this.
No. They can give you, I don't know if they can give you the angle. I don't know. Like, for example, the original reading was 6729, like that, right? So they might.
Yeah, but that's just like altering the formula, right?
Yeah. But what I have basically, I've never seen that question, but when I teach people like the syllabus in detail, I say that if they are looking at D1, right? So let's suppose if they're saying you want to find what would be the reading after D1, right? Like that. So what you do is, because this is like in this straight line, so 6 plus 7 is going to be 6 plus 7 is
13.
13, and 2 plus 9 is going to be
11.
so this would give you like the next storage in computer pixels is going to be 13, 13, 11, 11. You understand? Like that.
Oh, okay.
Like that.
And they can ask the same for like before D1? No, like they can give these values and ask us to
after D1. Yes,
yeah.
maybe if they ask you. So suppose now the new readings we have were 13, 13, 11, 11. And now they will say, okay, let's find D2. So D2 is like this, right? In this angle. So it's going like this. You understand? So now what will happen? 13 will come here. 13 plus 11 is going to be
24.
24 and 11. So in this line, there's nothing else. Now, the next thing that's going to happen here, I'm going to make it once only. Okay. So next thing it will have is that, sorry, it has to be like in the line so you understand. Sorry. I'll do it this way. Okay. So now it will be like 24, 24, 13, and 11. Do you understand? Like that.
Okay, and they can continue this, right? Like.
Okay, and if they go here, now the new reading on the which is saved is 24 and 13, 11, 24. And now where will they continue? Continue like this, because it's like down. So 24 plus 11 is 35, I think. 13 plus 24 is 37.
37. Yes.
Right. So the next reading on this pixel would be like here, which means 35, 35, 37, 37. Do you understand? Like that.
Yeah. Okay. I got it.
And then if you do this, like they will never like give you this much. I don't think so. That would be very cruel of them. And the last one would be like this. You would have to move this here. Now 35 there. 35, 37 is
72.
72. Okay. And 37. So the next reading will be like, here. And they view this. So it will be 72, 72, 35, 37, like that. They can do this. Do you understand?
Yeah, but it's not that bad. Like it's still the
No.
same concept, right?
I've never seen this question. Like they haven't moved it here. But I've seen this a lot. So you should remember this. Okay, you get it?
Yes, sir. And one more thing, it's not related to this, but how much of transformers is removed? Because it's still in the textbook, like the basics of it, like the IGCSE concept of it.
So in the syllabus, they've written that transformers, like it is assumed that the knowledge of the transformers from the IGCSE should be intact. Okay, something like that. In my opinion, for transformers, they might give you, like in in IGCSEs we had a formula, NP over NS equals to VP over PS. Okay, so one thing. And the other thing that they might ask you is the power in transmission. Like, why do we step up? And why do we step down? Okay. The answer is simple for this one, that power is voltage times current. So basically, you increase the voltage for the same amount of power to reduce the current. And why current should be reduced? Because if large current flows, then heating is done through the transmission, and that is a power loss. Do you understand?
Yes,
And
sir.
why something is
Second,
stepped
you
down? Yes.
No, go ahead.
Why something is stepped down? Because you need to run domestic appliances, which basically require less voltage. That's the only thing you got to remember. That's whole IGCSE concept. Okay.
Okay, sir.
Yes, Munif.
Sir, do you have any notes on transformers?
You want to take screenshots?
No, I want notes if you have.
I do have them, but I discarded them once it was removed. So you can take screenshots right now from the old ones. Oh, no, sorry. I think, wait, A2 group somewhere here. No, this is not it. A2. Let me find. Wait. Transformers were in alternating currents once upon a time. Wait a second. Yep. No. Then there must be electromagnetic induction. Yes, they're here. So this was like,
Can't you just share this?
I can share this, but construction is not required. Maybe operation a little bit. I don't know. And then they're quite advanced. Like there are graphs as well. I don't think so. It's required. Like I can send you my IGCSE ones if you want.
Yeah, okay.
I'll send you the IGCSE ones because these are like advanced, And I don't think so it's required, and you might get confused that what to do, what not to do, right? So I don't want to.
All right, sir.
Anyway, so a photon of wavelength collides with an isolated stationary electron, and then the photon deflected elastically by electron. Elastically. Do you guys know what does elastic collision mean? Just for my knowledge, I just wanted to know.
So no energy losses.
No, it's not that. It means kinetic energy before collision should be equal to kinetic energy after. Obviously, the total energy will be the same, but that's what elastic means. Anyway, that's from AS. You guys should remember this. All AS knowledge is absolutely assumed. Okay. So, what is meant by a photon? Photon is a quantum of energy of an EM wave, EM radiation. Okay. Now it says draw an arrow to indicate the approximate direction of motion of deflected electron. So this is a deflected photon. So it should be towards this point. And why do you think it should be this way? Because no matter what, you guys need to understand this is AS actually. In AS, you guys should understand that the momentum before and after should be equal, which means whatever the momentum you have here you must have the same momentum here. Otherwise, it doesn't work like that. Is it clear?
Sir, can you please repeat that?
Yes. So you might remember those questions of two-dimensional momentum from AS where two bodies would actually collide. One body would go here, the other body goes here. Remember this?
Yes.
The reason this would happen because momentum is a vector quantity, which means this body will have two components like this and this. This body will have this component like this and this. Obviously, the momentum horizontally, the momentum was there. Vertically, the momentum is zero. So these two should be the same as mv, the horizontal momentum. Before and after it should be the same. But these two are equal and opposite. They should cancel out with zero. Otherwise, momentum is not conserved. Do you get it?
Yes, sir.
So in order to conserve the momentum, if one is going in this direction, the other must go in this direction. So its vertical components just cancel out. Okay, so this should be something you guys should always keep in mind. In any interaction, there are a couple of things like I need to teach you some of the AS here. So a couple of things that you guys need to remember. So in any interaction, you guys should remember two things. Momentum must be conserved, okay? Because otherwise the law of conservation breaks. The other is charge must be conserved. And the third thing is mass energy must be conserved. And the fourth thing is number of particles must be conserved. So these are the four fundamentals that must be kept or upheld if any interaction happens anywhere in the world. All right, so this must be true. Anyway, so going down, calculate the momentum of the deflected photon. Okay. Now, it can be done by obviously photon is a wave, and the only way wave connects with the momentum is through de Broglie's wavelength. Now, the photon has a wavelength of 544 nanometers. So I'm going to write 544 times 10 raised to minus 9. Planck constant is 6.63 times 10 raised to minus 34. If you don't know, you can find it in the data sheet. And what you get for this? Yes, please.
1.22 times 10 raised to minus 27.
Minus 27. Okay. Then says energy transferred to the deflected electron. Okay. You could do this. So E equals to hc upon lambda. But the fact is, there has to be some other information. Oh no. Wait a second. We had the photon initially with this much of. Oh, okay. That is interesting. So this means that now we got to use this equation, but in a different way. So total energy must be conserved, which means some energy will be going to deflected photon. Energy of deflected photon plus energy of electron. All right. So we want to find this, which means we got to subtract these. So energy of electron would be equal to H E equals to H C over lambda minus HC over lambda. So this is for the original photon, and this is for the deflected photon. Okay, so that's what you're going to do. So we can take HC as common. So if we take that common, so energy will be equal to 6.63 times 10 raised to minus 34 times 3.0 times 10 raised to 8 times 1 over the original photon was 540 times 10 raised to minus 9 and minus 1 upon, okay, I messed it up. I'll move it somewhere. 544, I think. You know? 544. Okay. 10 raised to minus 9. Okay. Let's move it somewhere else. Let's move the whole thing. No, let's move this whole thing up. Okay. Can you please find this value? This is a tough question. This is not easy. I think so. There's a high chance of making a mistake here.
Two point seven times 10 raised to minus 21.
Joules. Okay, good enough. Then says another photon wavelength 540 collides with isolated stationary electron. Explain why it is not possible for Explain why is it not possible for deflected photon to have wavelength less than this? Okay. What does that mean? Another photon of wavelength 540 collide with stationary. Why it is not possible for deflected photon to have wavelength less than 540? So less than this, like energy of photon, if this is less, it means it will have more energy. So why is it not possible? Why it is not possible for the deflected photon? Oh, okay, sorry, my bad. I understand now. So this is he's talking about incident photon, very confusing. Incident photon, and then he's talking about deflected photon. It says if the incident photon has this energy, why is it not possible for a deflected photon to have energy less than this? How will it get energy from? The electron has no energy, right? So electron can't give energy to the deflected one. So you can't just increase energy. There has to be conservation, right? So that means that a lower wavelength means greater photon energy. So since electron has no energy because it's stationary, right? Initially. So the total energy cannot increase. Do you guys understand this? There's only one way that electron gives it energy, but electron cannot because it has no energy of its own. It's just stationary. That's why. All right. Okay, we have one more question. I thought this was finished. This is so long. Why?
Sir,
Yes.
can we say after collision the photon loses energy, so it's not possible for higher energy?
Yes, that's what I'm saying. That it's not possible to gain energy. Yes, it can lose energy to give it to electron, but the total energy would remain the same, right? You can't gain energy. It would be by law of conservation then. All right, give me like 20 seconds, please. Okay, I'm back. So let's move on to the last one. So it says iodine is a radioactive isotope with decay constant. What is meant by radioactive? So radioactive is basically property of an unstable nucleus. Oh my god. Oh my goodness. What is happening to my spellings? Okay. Nucleus that emits radiations. Now, decay constant is the probability of decay per unit time. That's the definition. Now going to the next. It says some water becomes contaminated with iodine 1. The activity of iodine in 1 kg of water is this. Determine the number of iodine atoms in this. Okay, we can do this. Activity is given by lambda n. The issue is we do not have decay constant. We do. That's cool. So we have the activity as well. So n will be 560 divided by 9.9 times 10 raised to power minus 7. What you get?
Five 5.7 times 10 raised to 8.
5.7 times 10 raised per 8. Cool. So regulations require the activity of iodine in this to be less than 1.7. Okay, so calculate the time delay the contaminant water to be reduced. Okay, so we gotta do A equals to A naught E minus lambda T. How to find this time? So initial activity was 560. Final act, oh my goodness, 170, and initial was 560. Okay, E minus lambda was 9.9 times 10 raised to minus 7 times T. So 170 divided by 560. Then you take ln. So it's going to be ln 170, 560 equals to, this will come down, E will cancel out. Can you find time, please? $14 days. Okay, you converted it already. It should be in seconds, no? So time will be in seconds, but you have to divide it by like, okay, Kartika said this is like 6 seconds, and now you need to convert it. So how do you convert it? You just divide by uh, to basically divide by in days. You need 24 hours in a day, 60 minutes and 60 seconds, and that would be 14 days. Okay. All right, and that's the end of it. All right. So in this paper, if you've understood this, we have basically left almost like, I don't know, 1, 2, 3, 4, 5, 6, 7, and one more. I think I left somewhere. 7, and this one 8, 7, and 6.
19 marks, sir.
19 marks.
Yes, sir.
19. So and that would be 100 minus 19 is going to be 79? 81, sorry. 81 divided by whatever your score is, you multiply it by 100 then, and then you find the aggregate, okay? So let's see. This seemed fairly like normal paper. It was not very difficult, not very easy. So 4-1, yes, it wasn't. So 59 and above, if you're doing it, then very good. If you're not, please try to check with me which. Now, the thing is, the idea is that you guys need to review your papers and see where you're getting, like where you're losing marks constantly or consistently, and then do those chapters again, please. That will help you improve, okay? All right, then. If you guys have no questions, then we'll
Sir,
Yes.
last time I asked you if you had a document with the things you're supposed to write in P5, like corresponding safety and stuff. For example, regarding